So, my name is Hermann Kroll, and today I present you our work, Narrative Query Graphs for Entity Interaction-Aware Document Retrieval. This is a joint work with Jan Christoph, Morris, Johannes, and Wolf Thilo Balke. Let me start with a short motivation to our topic. So in the scientific domain, if you are looking in retrieval systems, you are usually limited to keyword-based retrieval. That means you can enter your information need as a set of keywords, and then you will get some documents returned, for example. But we see two major limitations in these systems. On the one hand, it's challenging to specify interaction between keywords. Let's say you are interested in a drug like metformin and the disease diabetes mellitus. If you want to specify that you are looking for treatments, then it's something or somehow difficult to specify this precisely. You may enter the word keyword, but it's not clear which additional keywords you can use and how you can directly specify how these both keywords should be connected. And then, in addition, it might be very beneficial for you to generate literature overviews. Let's say you are not interested in a specific disease, you want to have an overview about the literature, which diseases are treated by some drug or something like that, then you would need a variable or placeholder, and this is usually not supported by keyword-based retrieval. So the main idea is that if a user has this information in his mind, then keyword-based retrieval lets some question opens like, how can I formulate placeholder? Is it possible, or should I leave the keyword out? And how can I describe the relation? And that's why we propose narrative query graphs, so that he can directly specify the entity he's looking for and how they should interact with each other. And especially if you want to use variables, he can do it in this way. The first question could be, why not building knowledge graphs and we are happy? That's not so easy, because knowledge graphs usually have a different viewpoint. They are large collections of knowledge, and they usually store structured information about entities. So let's say known properties, masses, and something like that. And so we have a large graph of information. But we are interested in narrative behavior. So, for example, how do entities interact within one line of arguments, and which statement might lead to a second statement? So the context, the study details, we are interested in these things. And this narrative behavior, or this narrative scope, is usually not in the scope of knowledge graph designers, because they build knowledge graphs as structured repositories of information, let's say it. And I really like this image on the right side here. A knowledge graph might be seen as entities which interact with each other, and we see narrative information as one big scope. So the green scope here, this could be one document, and in this document information are happening. So entities do interact with each other, and this might lead to some other observation, and this is a narrative information, and we want to help user to retrieve these information from texts. So if you simply extract statements out of documents and put all together into one single knowledge graph, you usually lose the connection between statements. And this is something which we would like to prevent. Our narrative discovery system contains of two main phases. So we have the pre-processing step, which takes a document collection and transform each document via entity linking and information extraction into a document graph. So instead of representing a document with a text, we represent a document with a graph where the nodes are the entities and the relationships are their interactions. Then we clean the data and put everything together into one structured knowledge repository for querying purposes. On the other side, the user can formulate his information need as a structured query. So let's say I'm thinking about the entity A, and it should be in the relation B to entity C or something like that. And this is my query. Metformin should treat diabetes and it should be administered as a tablet. And then we perform a graph pattern matching, return the matches, and visualize the results in a structured way for the user. The first question would be, how can we do the extraction step? And this is something which we have published in this year's JCDL. So we have published a toolbox for the nearly unsupervised construction of digital library knowledge graphs. And the main idea was to use methods which do not need training data in the extraction phase. So if you use the toolbox, you only need an entity vocabulary and a relation vocabulary. Of course, because we build upon open information extraction, for example, you may lose quality in practice because supervised methods might be better. But this is out of scope for this paper. If you are interested in more information and how we have done the extraction step, please have a look at our JCDL paper. Let me directly jump to our prototype. So the prototype mainly consists of 3 steps. The user can enter the query, a graph pattern matching will be performed, and then the results will be visualized to the user. And now I switch back to our narrative prototype to show you the interface. So let's say we perform the example search about metformin and diabetes. Then we can start entering a subject. Let's say we enter metformin. And we are interested in one relation, so we can have a look about the available relations, and we are interested in the treats relation. Then we have metformin treats, and we are looking for diabetes mellitus treatments. A user can select this term and perform the search. Then results will be returned and shown to the user. So we show the title, the journal, the author information, and if the user is interested why a document matches his information need, he can click on this provenance button, and then the sentence will be shown and it will be explained why the document matches the query. Besides, we could add more information. Let's say we would like to add a different fact pattern, and we click on the add button. And now let's say I want to have an overview about metformin again and the administered dosage forms. And instead of entering tablet or injection, for example, I write something like a variable here. And now I'm looking for the following information need. In the scope of the document, metformin should be used as a treatment for diabetes, and I'm interested in which dosage forms have been investigated before in the literature. And now I can perform the search, and the system will reply with a list and say, okay, I know 116 documents which talk about a general oral administration, 44 documents about an injection, for example. And I can click on this list, and then the documents will be uncollapsed. And again, users can click on the provenance button to get their matches explained. So let me switch back to our presentation again and move on. The obvious question is, how can we evaluate if our system is useful in practice? And therefore, we have done 3 evaluations in sum. The first part was in quantitative evaluation. So we have formulated 6 narrative queries and asked 2 biomedical experts to manually label 100 abstracts and 50 full text, whether the information need is contained or not. And then we can compare our system to existing baselines. And we have chosen one mesh-based baseline. So mesh are the medical subject headings of PubMed. They are manually assigned to a document and they describe which entities participate in the document. And in the latest developments, mesh also includes subheading. And a subheading describes how the entity is used within the document context. For example, drug therapy assigned to a drug means that this drug is used as a drug therapy in this corpus. And we have compared our system to such a manual created baseline, and we are achieving a similar high precision and a moderate recall. So we can outperform keyword-based retrieval, and we are similar to a manual created baseline, which is not available for all digital libraries. Of course, performance is another very important factor. So we have measured the performance, and it depends on your query. Most of the queries can be executed very fast, so within 20 milliseconds for a one fact pattern, for example, or 51 milliseconds for three fact patterns. And if you use variables, it depends on how general your query is. If you are querying, for example, all drug disease treatments in literature, this will take some time. If you are more specialized, then the query will be performed much faster. And if you would like to know more about both, then please have a look at our paper. In this talk, I would like to focus on the qualitative evaluation. So we have asked 8 biomedical experts to really understand how they work, how we could help them, and how they could use our system, and what works well and what does not work well, for example. And therefore, we have done 3 um, evaluations with them. First, we have performed think aloud experiments. So we asked them to share their screen and talk about the literature searches, talk about things that go good, that could go well, things that don't go well, and so on. Interviews, we explained them the prototype, and then we have one interview before using our prototype and one interview after using our prototype. And to collect feedback on an empirical level, we had a closing questionnaire. And now I will go through each of these evaluations. So first, in the Think Aloud experiments, we talked to them about the typical literature searches. So what they do, what information do they search, how do they search, which search engines do they use, all this kind of stuff. And we summarize these findings into 2 categories. We see that there's a recall-oriented search paradigm. So there are searches such as finding works of author X, or finding works about the keyword Y, or going through citations lists. So therefore, the users do not want to miss a hit. But on the other side, there's a different use case, a precision-oriented use case. For example, they talked to a colleague about some idea in their mind, and then they quickly want to check if the idea has already been investigated in the literature or not. And therefore, they quickly want to find a match. And here it is really important to support such a use case. Then we gave the prototype to them and let them 3 weeks time to play around with the prototype, search for their typical use cases, and then they gave us feedback on a qualitative level. So first, using narrative query graphs is different and more complicated than keyword-based searches. You have to think about which relation you would like to choose. You have to think about the precise entity and something like that. In addition, the formulation of variables was too cryptical for users. So we had these notation with the leading question mark and then the X, and in brackets you could specify the entity type, and this is something which was too difficult for our users, and they preferred something like just writing drug. In addition, users are restricted to a predefined set of entities and relations. So, for example, we did not have a vocabulary for pharmaceutical methods, and so they cannot use or they cannot search for these methods. And this is something which you have to handle in an application. On the other side, there were advantages. On the one hand, the users argued that narrative query graphs indeed retrieve precise hits quickly, so they could quickly find a match for their use cases. The provenance information, so the information why a document matches, was especially helpful to quickly understand if it was a correct match or if it maybe is a wrong extraction or something like that. And in addition, they really appreciate the feature of variables in their searches because therefore they could state a complex interaction graph and then use a variable at some node and say, generate me an overview. And this was helpful to see, for example, which dosage forms were already been used in the literature, what has been tried out, something like that. And therefore they can generate overviews about the latest literature, and this was well appreciated by the users. In the end, we have done a questionnaire, and the ratings are based on the Likert scale. So 1 means disagreement, 5 means full agreement, and we asked them several statements and they should rate these statements. And in this talk I just have picked out 4 important statements. The first one was, the prototype provides precise results for my questions. And indeed the users had a good agreement here. In addition, when searching for or verifying a hypothesis, I would prefer the prototype to a search using classical search tools. And here we have also a good agreement of 3.4. In contrast, if they search for related work, then they are quite reluctant and say something like 2.8, which is a low agreement, I would say. And in the end, we asked the question, if they could imagine to use our prototype in their literature search, and indeed they had a good agreement again, so 3.9 here. Discussions. Narrative query graphs come with limitations. They are more complicated than keyword-based searches on the technical side, but also on the user and the front-end side. You need to have intuitive user interfaces, for example, and usually you will lack recall. So all natural language processing tools do not work perfectly, and if you restrict, for example, extractions to a sentence level, then you only have statements inside a sentence and not across sentences, and this will lack recall by definition. But we see this dire need for precise document retrieval. 7 of 8 of our users agreed that the majority of searches is precision-oriented and that they prefer our narrative service for such searches. And the verification of a hypothesis seems to be a real use case here. So let me come to a conclusion. Narrative query graphs offer a precise and structured literature search. There is a use case, and they could be implemented today with existing methods. But it's important to note that they should not replace traditional discovery systems. So for example, if you are looking for related work, then a keyword-based system might be more suitable. And the idea of narrative query graphs are a step towards narrative information access. So in our big vision, users may formulate their query as a scientific narrative. So they may say, okay, I'm looking for these statements and they should lead to the conclusion that some drug has a good effect, for example, or something like that. And I'm interested in this whole discourse. Is it plausible or not? And then a system should try to plausibilize this structure by finding evidence for it. But this is the big picture, and narrative query graphs are a first step in the sense of that we could match one fact pattern against a single document for now. So thank you for your attention, and if you have any questions, then just contact me via mail or on Twitter. Bye!